What's up, everybody? Welcome to Omnipotent Health and Fitness episode number 10. We have two guests today. Our first guest is Dr. Nick Norwitz. Nick is a certified metabolic health practitioner who graduated valedictorian from Dartmouth College, majoring in biology and biochemistry. He subsequently completed his Ph.D. in just 2 years at the University of Oxford, studying ketogenics and metabolism. And as if that wasn't enough, Nick is currently enrolled in Harvard Medical School and has already written an entire Mediterranean keto-friendly cookbook and has published multiple peer-reviewed papers in topics ranging from neuroscience to heart disease to gastrointestinal health. Now, our second guest is Dave Feldman. Dave is a software engineer by trade, but after learning he was pre-diabetic, turned to the ketogenic diet to reverse his diabetes. While successful in reversing his diabetes, he also noticed in subsequent labs that his LDL-cholesterol had skyrocketed since adopting the ketogenic diet. However, instead of waiting for someone else to figure out why that was, Dave decided to take things into his own hands. He formed the Citizen Science Foundation and coined the now famous term lean mass hyperresponders. That's LMHR for short. Dave has now spent just under the last decade becoming a bona fide superstar in the ketogenic space. And through his famous N of 1 experiments and relentless work ethic, he was able to garner enough support to crowdfund a massive prospective cohort study to learn if lean mass hyperresponders are actually at risk of heart disease. So please help me in welcoming the cautiously optimistic engineer turned citizen scientist and the real life Doogie Howser, Dave Feldman and Dr. Nick Norwitz. Dave and Nick, welcome to the show.
Thank you so much, Albert, and for having that super generous introduction.
No, of course. Thank you. So I like to kind of start my interviews learning people's origin stories. Researching the two of you has been incredibly fun. And I was hoping we could start with you, Nick. Your story is particularly notable. And I was hoping we'd start with why you ended up doing the ketogenic diet, particularly how it improved your health, specifically with ulcerative colitis.
Yeah, for sure. I'll try not to be long-winded since I usually run a risk of that. But basically, I started off like most people, a keto skeptic. I was kind of, went by the rule books, dietary guidelines, knew how to eat, my pyramid, then my plate, and was overall just like a on the surface healthy person, kid until around the age of 18. And I started to develop various issues, including, like you mentioned, ulcerative colitis, which, if you know anybody that has ulcerative colitis or Crohn's disease, can just be a debilitating condition. Like social events, academic endeavors, anything just becomes really burdensome. And it got quite severe for me to the point that I was having a lot of weight loss, a lot of terrible bloody diarrhea. And after graduating Dartmouth and going to Oxford, right around ending up in Oxford, I had some of the worst flares of my life. And I ended up in the ICU with like severe bradycardia. My heart rate was in the 20s. Nobody knew what was going on. By that point, I had tried a bunch of different medications. And various diet and lifestyle interventions. Basically, you name the diet, you name the lifestyle intervention, I had tried it. And at the bottom of my list to try was a ketogenic diet, which I eventually tried out of pure desperation. I had no expectations that it would help. But for me, it was really like a light switch. My bleeding went away. A lot of my worst symptoms went away. I got some energy back and started to be able to engage in life and just feel fantastic. My inflammatory markers dropped. And there was, this period when I'm like, this is amazing. This is amazing for me. Now, at that point, I thought I was still a zebra. I had gone through some weird stuff and I'm like, okay, I tried some weird stuff. I tried a weird diet and I reacted uniquely. But as I started to get really interested in it and dig into the scientific literature and get engaged in the low carb communities, I started to observe this really interesting motif. And now I like to say, and I say this over and over again, so if you've heard me say it, I apologize for sounding like a broken record. The most remarkable thing about my story is that it's not at all unique. That there's this motif of patients who have some sort of metabolic disease, be it inflammatory bowel disease, pre-diabetes, diabetes, obesity, various mental health conditions, and they become a little dissatisfied with the progress they've made via conventional medicine, and they'd try something a little bit outside convention in the form of carbohydrate restriction, often ketogenic diets, and have remarkable improvements. really remarkable improvements. I have friends who have dropped their HbA1cs from like 12 to 14 to 5.5, come off all medications, really, regain their life. We have some colleagues who are doing work in mental health with reversal of schizophrenia. It's really astonishing. And that really not only changed my life, but my career path. I always knew I wanted to be a physician scientist, but I didn't know how I wanted to make my impact in medicine, what I wanted to study. And now I know that I want to study metabolic health, metabolic medicine, because I think that there are tools available now that can help people suffering from some of the most debilitating, population-wide chronic diseases, diabetes, obesity. I think there is an answer, and we just need to, do the studies, provide the public education, and I think, we have to stem the tide of these conditions, and there's opportunity to do it in focusing on food as medicine, which, as froofy as it sounds, has a ton of hard science behind it, and is super cool. And I like to cook, so win-win-win.
Absolutely. That's a beautiful story. I think it's really important to note something that you said is that the ketogenic diet has really worked these amazing things for people who have tried the gamut of various therapies. And so for some, it's really not an option to come off the ketogenic diet, which will become important later on, as we'll see. So Dave, maybe we could get a quick background with your journey. What made you go ketogenic, and what made you quit your job as a senior software engineer and pursue all these crazy medical questions surrounding cholesterol?
Yeah, my story kind of reads like fiction because I really had no interest in nutrition or medicine or even just scientific endeavors. I was very much, from the youngest age, loving engineering, and particularly software engineering. I loved writing code. I loved systems. And so in 2014, I had gotten blood work that showed my A1C, which is a marker for diabetes, of course. It was 6.1, which put me right in the middle of pre-diabetes. And I was like, oh, it's probably because I was on some, deadlines at the time. I'm going to clean up my diet, make it better. The year after, I got the test again, and it was again a 6.1. And at that point, I started researching, what can I do to stop getting diabetes like my dad and all the rest of his family, because I don't want to go there. And at that time, a LCHF diet, low carb, high fat, was becoming big. Keto wasn't actually that big at that time in 2015. But as I'm looking into it, I'm thinking, well, wait, this sounds great, but I'm eating a whole lot of saturated fat and consuming cholesterol. Isn't my cholesterol going to go high? I'm asking these diabetic forums, and they're like, oh, well, that actually rarely happens. It's, just to some folks, and it's very unlikely. I thought, okay, fine. And at around the time that I started the diet, both my dad and my sister get inspired to do it because they had some other issues themselves, including what I just mentioned. My dad had much more severe type 2 diabetes with an A1C of 8.2, I think, something like that. So he was getting close to having to get the exogenous insulin and so forth. Anyway, all of us, we would all improve very rapidly. They, around 6 months later, get their blood work before I get mine. And I warned them that there's a chance their cholesterol might go up, but probably only a little bit. And sure enough, it did go up, and only a little bit for both of them. I get my test, however, and my cholesterol goes way high. It doubles. And at that point, I thought, oh my gosh, what I do, I must have made some kind of mistake, but it doesn't make sense. My first degree relatives didn't have this effect, but I did. And that already made me curious. And so for 2 weeks until my next test, I started learning everything I could about lipidology, the study of lipids. As you probably know, if you have engineers in your life, we tend to think highly of our ability to try to educate ourselves. So that's what I started doing. And sure enough, I saw what I still contend to this day, that it's actually a network. What's inside our body that moves around lipids is actually a fairly sophisticated network for, what you could call the human operating system. And at that point, I started doing a number of experiments, and I found that I could change my lipid levels around substantially against different food plants, which we can get into a little bit more in detail later. But as far as the backstory, as that happened, I started reporting it more and more into the community. And I kind of gained much more of a presence with this kind of model that I was kind of putting together as to what might help explain why this happens. But the irony, and how I kind of want to tie it back to Nick real quick, the irony is I'm still an engineer. I'm not a formally trained scientist. And so while I was good at putting together the blog posts and the presentations and getting very methodical in these experiments, I was not practiced at putting together papers, or for that matter, exploring a lot of the other aspects of the literature that might further flesh out the model. And then literally just Nick, a year ago today, we started
Feels like 10, but yeah.
I know it feels like so much time has passed, but literally think about this. My origin story, as I mentioned, started in 2015. About half a decade later, plus a year, I start connecting with Nick, and that was my switch. Nick was, at that point in time, he was everything that we needed. He was, in my opinion, like the closer to the model, and that at that point we synergistically started working together really well. And with the help of a lot of people, we'll also have to mention separately, that have supported this. We've been able to get this research put together, and it's now not only coming to the literature, but as you know, 48 hours ago, we launched the lipid energy model paper, which we're very proud of how well it's doing and so forth. But that's our origin stories in a nutshell.
Yeah, absolutely. I had the privilege of reading this paper, and it's incredible, and congratulations on that. To tie something back to Nick, I will say, researching Nick and reading that he is attending Harvard Medical School, I was not at all surprised, because I was like, well, that makes sense. This guy is 100% a closer, and I 100%, believe my early on joke with the Doogie Howser statement. You're incredible, Nick. So, on that note, so my audience really ranges in knowledge, from those who probably follow your guys' work all the way to those who have never heard of lean mass hyperresponders at all. So I'd really like to start from the ground floor and kind of build our way up there. So Nick, I was hoping if you could just kind of broadly refresh our understanding of the ketogenic diet, what it is, and you already mentioned some of the benefits of it, but if you could just quickly go over that as well, just in a global sense.
Sure. So a ketogenic diet is a diet that is defined by the state of ketosis. So ketosis is a metabolic state where your body is turning fat into, well, fuel, but part of that fuel is ketone bodies to fuel your brain and other organs. So we evolved to be very good as organisms at ketosis because we have these big brains that need fuel. They generally rely on glucose when we have a lot of dietary carbohydrate available, but when it's not available, we kind of have two options. We can either eat up our muscle tissue, say we're during a prolonged fast, or break down protein to feed our brain, which evolutionarily is not ideal. You don't want to break down all your muscle protein, or you can turn your fat into a digestible form for your brain. That is ketosis. And so ketogenic diets are diets that induce a state of ketosis. They're generally moderate protein, low carbohydrate, high fat diets. They vary in macronutrient composition, but if you wanted to give like ballpark numbers, I would say 70-ish% fat, 20-ish% protein, and definitely fewer than 10% carbohydrates. Again, it can vary person to person, but that's around what the ratios would be. And then you make these molecules called ketone bodies, which, and I don't want to go on too much of a tangent, but because my PhD was in this area, I just want to point out that, when people talk about ketones as fuel for the brain, as I just did, or just fuel for the body, that's only hitting one half of the picture. Ketone bodies, especially beta hydroxybutyrate, are incredible signaling molecules. They have G protein coupled receptors on the surface of cells. They can go into cells, modify, the activity of histone deacetylases and change gene expression. They themselves can be post-translational modifications. So if you heard about like acetylation or methylation, there's beta hydroxybutyrylation of like 1,400 different proteins. Point being, these molecules are really hormones that can revamp metabolism, which I think is really cool. One of the reasons I'm interested in that state. But ketogenic diets have been used therapeutically, at least for epilepsy, for now over 100 years. So they can be used in pediatric epilepsy that's not well treated by medications, with actually pretty great effect. And more recently, they've come to be popular for the treatment of a much broader spectrum of metabolic health conditions, other neurological conditions. There's randomized controlled trials in, say, Alzheimer's and Parkinson's, now being explored for like autoimmune and inflammatory conditions. There was just a paper out in Nature about ketones and colorectal cancer. And then, of course, obesity and diabetes. So via various mechanisms of carbohydrate restriction, there's a lot of potential for ketogenic diets in treating these various maladies. And we're not going to delve into each of them right now, but that's kind of a broad overview of the ketogenic diet. I just realized I'm going into like, I'm usually much more long-winded. I feel pretty concise and direct, and I think I'm imagining you as like my senior resident. So for everybody who doesn't know, Albert's a resident at Massachusetts General Hospital, where I'm going to be doing my my clerkship rotations as a medical student. So I have a little bit of performance anxiety right now, FYI.
Stop. I think it's the opposite. Honestly, the two of you have more knowledge around cholesterol and the ketogenic diet than I can probably safely say 99.9% of physicians out there. So believe me, I am the student sitting at the feet of my teachers in this scenario, 100%. But thank you so much. That was a wonderful breakdown of the ketogenic diet. It helped you with your ulcerative colitis, and Dave, you saw it firsthand how it reversed your pre-diabetes, and not just yourself, but in your dad and your sister as well. And then while you were tracking that, I guess it's commonly noted that a third of the people on the ketogenic diet kind of have an increase in LDL cholesterol, LDL meaning, in layman's terms, the bad cholesterol, which, people will get mad at me for calling it that, but in layman's terms, it is the bad cholesterol. And a third have an increase in LDL on the ketogenic diet, a third have no change, and about a third have a decrease in LDL. But then you noticed that there was this subset of people that had a really, really high increase in LDL. Can you talk more about that, and I guess how you came across the term of lean mass hyperresponder?
Can I just interject for 1 second before Dave does his piece? Because
Sure.
I want to, those third.
I know.
I just want to point out the magnitude that we're talking about. When you say like a third see an increase, when we say that, we're talking maybe a short-term transient blip of like 10 to 20 to 30 milligrams per deciliter. So I just want to kind of put that concept as a basis for what Dave's about to see, because the phenomenon we're talking about is like a whole different kettle of fish.
Yeah, thank you. Thank you for that additional context. It's very much needed. So at any point, please feel free to interject.
Yeah. So I just to literally, our first paper together is in doing an analysis on a fairly large survey group, granted some degree of self-selection, but for which we're actually looking at how much this association can be somewhat predictive against body mass and your starting triglyceride to HDL ratio. And so to kind of set this up a little bit more, whenever somebody throws out the third, I say, please go check out our paper, because it'll give greater specificity of what we think is going to be this kind of association. So rather than, as Nick had just mentioned, while it's true some people may see an increase in LDL, what we would posit is that a lot of this, and this will lead us back to the phenotype in a moment, what a lot of this is seemingly predictive of is sort of what your likely metabolic health state is and how lean you are. So if you are somebody, just Cliff's Notes based wise, if you're somebody who's already metabolically challenged, who's morbidly obese especially, but just generally very overweight, and you're going on a ketogenic diet, it's less likely that you're going to see your LDL go up. And for that matter, if it does, it's probably not going to go up that high. At least that's what our current data is very suggestive of, right? Now, again, this is, still survey data, and we understand that. But conversely, if you are going on a ketogenic diet and you're very lean and likely very metabolically fit to begin with, it's actually much more likely that you'll see a pronounced increase. And this is what I was kind of observing going back to 2017 when I'd first written the article denoting this phrase, lean mass hyperresponder. I know it's a bit of a mouthful, but it actually was sort of a change to an existing phrase of hyperresponder, which was getting used by some doctors in the area, like Thomas Dayspring and Peter Attia, for some folks. Very few at that time, but for some folks who saw this quote unquote hyper response. Now, it's worth emphasizing that there's kind of two waves to low carb. There's the wave we're used to from way back in the day with Atkins. And that wave was generally with people like I just described, those who tended to be much more overweight and would just try anything to lose weight. And so what the heck, If just having, if reducing your carbs had a big impact, they would do that. There weren't already a lot of people who were very athletic and lean who just happened to want to try low carb. In fact, usually the expectation was that you needed the carbs to fuel your athletic performance. And keto is really kind of brought in this new wave, and which is why there's this emergence of this new phenotype. So lean mass hyperresponders aren't just described by having high LDL. What I was observing was that there was also this higher preponderance of HDL and low triglycerides. So the cut points are an LDL cholesterol of 200 milligrams per deciliter or higher, HDL of 80 or higher, and triglycerides of 70 or lower. And it's worth emphasizing that each of those three that I just mentioned are already rare in their own right. Like in existing population data, it's already very unlikely to find somebody with an LDL cholesterol of 200 or higher, an HDL of 80 or higher, triglycerides of 70 or lower, each of those just separately, but all of them together. Part of our analysis is we were looking at the NHANES data set from the CDC. There's just 3 out of like
70,310.
Yeah, exactly. So it's extremely rare to have that combination. Well, after posting this article, again, back in 2017, I really didn't know just like how many people there would be. And as of today, we have a Facebook group full of lean mass hyperresponders and borderline lean mass hyperresponders and people interested in the research around it that boasts around 8,000 members. So it's absolutely a huge number. I would say that probably about at least a fourth in that group are bona fide lean mass hyperresponders. They hit all 3 of those cut points. Again, it's very much an emergent population. But there's a decent chance with any low carb doctor now that they already have a number of people that are lean mass hyperresponders under their care.
Yeah, absolutely. So, you mentioned HDL, LDL, triglyceride, and cholesterol. Could you quickly just break down, I know it's a broad question, but for the scope of understanding, I guess, the basics of your paper and your research, what those kind of 4 things entail?
For you mean 3 things?
Or sorry, LDL, HDL, triglyceride, and just if we could add in cholesterol in there as well.
Yeah. So okay. So what I think you mean is total cholesterol.
Right,
so if you get a lipid panel, you typically get those 4. You'll get total cholesterol, LDL cholesterol, which is typically referred to as the bad cholesterol, HDL cholesterol, which is typically referred to as the good cholesterol, and triglycerides, which is a measure of fat in the bloodstream. And more these days, like it used to be that they would look just at total cholesterol. More and more these days, they look to LDL cholesterol, the so-called bad cholesterol. And I think existing guidelines are that it should be under 100, which is why it's understandable that it'd be considered very concerning for those people who have, like I just mentioned, the cut point being 200 or higher. There's less than 3% of the population in NHANES that have an LDL of 200 or higher. So of course, this is already, and that's the floor, right, of lean mass hyperresponders, right? HDL cholesterol, the so-called good cholesterol, again, just to give you some perspective, the existing guidelines would say for men needs to be 40 and higher, for women 50 and higher. And again, for lean mass hyperresponders, the floor is 80. And we've seen many people have an HDL of like 100 or higher, 120, 140 even. And that's typically associated with lower cardiovascular disease. That's why it's often called the good cholesterol, is if that tends to be a higher number, it tends to associate with lower levels of atherosclerosis. And then triglycerides, a measure of fat in the blood, being lower is also generally associated with lower cardiovascular disease. It's also well known in the literature that those 2 in reverse is a profile known as atherogenic dyslipidemia. In other words, if you have low HDL and high triglycerides, you tend to be at a higher risk for cardiovascular disease. And those 2 are associated with, of course, metabolic syndrome itself. Those are 2 of the criteria in metabolic syndrome also.
Yeah, absolutely. So just to put things in context, why this matters, we just discussed all the therapeutic uses of the ketogenic diet. There are people who do use it for IBD, ulcerative colitis, Crohn's disease, and anytime they stray away from the ketogenic diet, they have flare-ups, which is a major issue. And some of those people are also lean mass hyperresponders. So their LDLs are skyrocketing. Some of them in, like you said, the floor is 200, and some of these go all the way up to the 700s, which is extremely high. And currently, the state of how things are operating, at least in the US, is that high LDL equals put you on a statin period because you are at very, very high risk, especially at those levels of developing atherosclerosis. And so, it's really quite important to figure out whether this population of people whom ketogenic diet seems to work amazing wonders for, but are also lean mass hyper responders with an increased LDL, whether they're actually at increased risk for developing heart disease or stroke. Just kind of setting the stage. Is there anything, Nick, that you'd like to add to that?
Yeah, a couple things. One, and this is just a total tangent. This stuff can get really complicated. So when we put out these guidelines, I just want to, I'm saying this in part to protect my friend, because I know people on social media are going to attack him for saying something like high LDL is protective, because there's always papers coming out adding nuance to that. In fact, very high LDLs, like we're seeing in lean mass hyperresponders, on a population level are actually associated with increased risk. It gets very confusing. But anyway, okay. I'm trying to decide like how deep I want to go with these things. I think one thing I want to emphasize, because this has come up since the publication of the paper and we can dig more into it, but the really fascinating thing, setting aside the risk for a second, we're talking more about the mechanism and the profile we're seeing. Okay. So, with these lean mass hyperresponders, we're seeing going from, again, normal pre-low carb diet LDL. So if you take lean mass hyperresponders and non-lean mass hyperresponders, baseline LDL is the same. But then you put them on a carbohydrate restricted diet and they develop this triad, a very high LDL. So median, I'm going to give the median levels for our cohort of 100 were 320 for LDL. That's median, or mean maybe, but it was median. And then 99 HDL, 49 triglyceride or something. Wow. So a pretty extreme triad. Now, what may occur to some people that are listening now, or may occur to you later, it certainly has occurred to many people just in the community, is like, oh, but it's just the saturated fat. Or, oh, it's your hyperabsorbing cholesterol. Or, something to that effect, or it's just a gene. You can't rule out, I mean, it could be that there are genes we haven't discovered, annotated. It could be just that. But I think the really interesting thing about this profile is, what we're seeing is this triad of markers and an inverse association between the LDL and HDL changes on a low carb diet and leanness. So the leaner you are on a continuum, the higher your LDL and your HDL rise. So this poses a really interesting biomedical question, is how do you get that? Like, how do you get that relationship from, say, associated with a change to a ketogenic diet? Because if you stop to think about it for a sec, none of those like some more simplistic explanations provide a complete explanation for this phenomenon. If it's just saturated fat, I don't know how you're getting the triad, and what's the relationship with body mass index? Are lean people preferentially eating higher saturated fat diet, or a saturated fat diet making them lean? I both think those are kind of like unlikely. If you're hyperabsorbing, what about people that are eating lower cholesterol diet, ketogenic diets, or, you'd expect higher baseline levels if you're hyperabsorbing? Again, we don't see that. And I can't identify or think about any like family of genes that would, again, manifest in this inverse association between BMI and the LDL HDL change. And again, a triad. So trying to explain this phenomenon, you can't go to the usual suspects, so to speak, to figure it out. So it poses the question, how are we getting these profiles associated sometimes with, like you mentioned, LDL levels so high? Most people think they only present in homozygous familial FH, which is a 1 in 1 million genetic disease, terrible disease. So how are we getting like, maybe a reproducible phenomenon, with LDLs equivalent to a 1 in 1 million genetic disease? Like, how does that happen? So scientifically, it's a huge, interesting question. And then there's the whole risk side of it. But I just wanted to place that framework because it's what really draws me to it intellectually.
Right. Absolutely.
Well,
And
and actually, if I can capitalize on that a little bit, because I do want to bring it back to risk and why it's of enormous interest to us. And naturally, Nick and I would caveat that we don't know yet its association with risk, and we can certainly understand why many people would make considerations with their doctors on different steps that they may be taking to lower it. This is part of why our first paper we're very proud of, because many people who are uncomfortable with their higher LDL can look to the paper where we show that those people who have taken interventional steps. We have a great case series by one of the co-authors for where there were interventional steps of adding just a little bit more carbs, 50 to 100 grams of carbs a day, which fits with our model as to why it is that their LDL would be lowering, because we think a lot of this links back to hepatic glycogen stores, for example. But with that said, bringing it back to, hey, why do we observe this higher association with cardiovascular risk when setting aside LDL for a moment and looking to HDL and triglycerides? Well, it could be lean mass hyperresponders are actually providing us a kind of a new window into that opposing profile that is atherogenic dyslipidemia. Could it be that the higher levels of triglycerides detected in the blood for those folks who are seeing this higher rate of heart disease is a lack of utilization of the fats in the blood, right? So you've basically got a parking problem. You're having an inability to metabolize the lipids, and this can be as a result of very many different things, but it can also, our model, I think, helps to also establish why it is that the lower HDL can be further indicative of this issue with the poor metabolizing of the fats. And this is where lean mass hyperresponders may provide something truly novel, because typically in the profile of atherogenic dyslipidemia, you don't just have low HDL and high triglycerides, you tend to have a higher preponderance of small, dense LDL particles. But this isn't what we see with lean mass hyperresponders. They tend to have a very cholesterol-rich but triglyceride-poor LDL particles in their species population within their body. How much would we observe that this associates with atherosclerosis is something we're very interested in. So of course, I'm going to take the opportunity for a quick plug, and that yes, I've been very fortunate that we've been able to crowdfund a study around lean mass hyperresponders that's going on right this moment. We actually are getting people scanned at the Lundquist Institute at UCLA. They're getting a CT angiogram and a first visit, and then 1 year later, we've got another visit scheduled for each of them where we're going to get a second scan and then be able to look at the longitudinal data. We were originally going to make it for 5 years, but our principal investigator, Dr. Budoff, actually said we should be able to see it because of the effect size. We should be able to see it easily within 1 year. So if this population does show with their sky high LDL, a clear progression of plaque. In fact, they actually should show up with plaque. There should already be a high level of plaque given our eligibility requirements are 2 or more years for the participants of this study. That's already going to give us a lot of data right there. And then we'll have a better sense of whether this phenotype is of a substantially higher risk like we would see with homozygous FH.
do you have any preliminary data yet that you can share on that, or no?
Not yet. We're completing the first recruitment phase. And basically at that point in time, I then turned, because of course I'm, as the organizer with the funding, I'm necessarily blinded from the data, but I'll get to turn to the principal investigator, Dr. Budoff, and say, okay, do we have novel data at baseline? And if we do have novel data, then we may be publishing it. Obviously, the one piece of novel data or not novel data that I'm hoping I don't get is there could be a call at any point in time where they go, oh, you know what? We've had to reject 50% of the participants because there's, clear plaque at baseline. So we should actually shut this down. Everybody should be going on cholesterol lowering medication. I haven't gotten that call, right?
Well, that's good.
Yeah. But thus far, yes, I'm not sure if I'm allowed to say how many people we recruited and scanned, but it's going along nicely. I'll just put it that way.
Awesome. And out of curiosity, you mentioned that you should be able to see something after a year. You're originally scheduled for 5 years with all of this. What is the population that they're basing that on? Or is there a paper that's already been established that shows that you would form plaques within a year with LDLs at, greater than 200 or anything like that? How do we know
Well,
that they would form within a year, I guess is my question.
There's existing data on high-risk populations that are hyperlipidemic. And hyperlipidemic, I mean, in the broader sense, in that, of course, folks who have hypertriglyceridemia, as in high triglycerides, alongside high LDL, that kind of thing, to the extent to where we can at least look at it against high-risk populations. But the other aspect to this is that we have existing data on FH, particularly homozygous FH. We don't have longitudinal CT angiography with FH. I wish we did, but we do have what we've already observed are manifestation of symptoms in this population. And of course, at the point where you've got symptoms, you can look at what the existing likely plaque volume is, occlusions and so on and so forth that are typical to explain things like advanced angina that unfortunately you do see with like children of FH at a large preponderance. In fact, we had a case study recently on a lean mass hyperresponder who had an LDL in the 500s, and for which there was not only a CT angiogram, but we had 3 different independent experts look at it. And in spite of being in these ranges for 2.5 years, the scans were completely clear. Now, again, I say this with understandable caveats. It's short term. It could be that, it will progress at a certain point in time. But the point is, we were able to look in that case study against existing data. There was CT angiography with children of FH, and there was like 6 cases, and of 4 of those 6, there was advanced plaque already at a very young age. Right. And yeah, it's unfortunate, but that's the closest we have. And of course, children with FH often don't have existing other risk factors, which is why they're an obvious comparison.
Right. And I guess just for the audience, familial hypercholesterolemia is a case in which LDL levels usually are pretty elevated, greater than 200, and usually mimics those that you might see in a lean mass hyperresponder. But I guess, correct me if I'm wrong, with familial FH, you can often have dysfunctional LDL receptors though, right? And that tends to be, we would think, is not what you would see in a lean mass hyperresponder. But however, that is like the closest population that we have studied as far as, looking at CTAs and whatnot. Is that correct?
Yeah. Correct. And not only that, it's worth emphasizing that that's where the existing lipid hypothesis, like that's one very strong anchor on one side of the hypothesis, is that they feel the lack of LDL receptor, that the lack of binding from the LDL receptor or mutations that effectively impact this are the reason it doesn't get cleared as quickly, and that it's that concentration gradient due to the lack of clearance that's the reason for the higher development of atherosclerosis, not this lack of lipid metabolism. But I'll concede, I tend to feel like we shouldn't take the lack of lipid metabolism off the table, because I think that is relevant towards development of atherosclerosis. But again, this is where lean mass hyperresponders will provide potentially novel data in this regard, because it's the only time that I'm aware of where we can get to these kinds of levels without monogenetic FH. Sorry, Nick, you were going to say something.
I was just going to add, well, first of all, reinforce what you both just said, that there's a distinction between having, high levels because potentially you're turning a pathway over faster, and high levels because you have a broken negative feedback system. So in FH, there's a broken lipid metabolism. And that doesn't appear to be the case in lean mass hyperresponders, in part because the phenotype's readily reversible with carb reintroduction, but also in the case report that Dave mentioned and in the case series associated with the first paper, we did do genetic testing for at least all the monozygous FH genes, and they were all clear, 6 out of 6 clear. No polymorphisms. In the one patient, we did a lot more advanced testing, and again, there was nothing that showed up on a whole exome or a gene panel of 141 genes that really could explain the phenotype. So in terms of mutations related to FH, we've only seen a very small population, but it doesn't appear to be the case. And I would speculate that in LMHR at large, there aren't like LDL receptor, PCSK9 or ApoB defects that are driving this. It just wouldn't be.
And part of how we can feel this level of confidence is the fact that we've observed this change, right? So people typically, and this includes with our study out of Lundquist, they had to have started with a lower LDL relative to where they ended up. And so to Nick's point, we already feel like it's pretty unlikely, given the quote unquote hyper response is already indicative of a change of what was before to what it is now, which is unlikely then to be genetically induced per se.
So you're saying at one point in their lives, they had normal LDLs. So it is unlikely that this was sort of a genetic phenomenon.
Usually almost their entire life.
Exactly.
Yeah. So for the case report example, the one Dave said levels went to like 500, 545, baseline LDL on a mixed diet was 95.
Right.
And then it went up to 545 on a mix, on actually a low saturated fat ketogenic diet, if you really want to add to it.
That's incredible.
The peak LDL was at the lowest cholesterol intake and the lowest saturated fat intake. It was like 82% unsaturated fat with less than 300 milligrams cholesterol intake. So it's like not the saturated fat or the egg yolks.
Yeah, no, absolutely. So I think now's a good time at this point, Dave, if you want to kind of take us through your lipid energy model, kind of bring the audience along for the ride, if you will, talking about the boats and transport of the cholesterol and the shipping and what goes up, what goes down. You do a much better job of this than I would. So I'm really curious to kind of learn along as we go.
Actually, I feel like I've kind of taken up a bit of the balance of time, and I really want to honor how much I appreciate Nick for first authoring this paper. Let me pass it off to Nick. Nick, why don't you go ahead and explain?
You sure?
Absolutely.
I like to hear myself speak, but I feel like I'm good at I enjoy writing. You've always been the voice of this, and it's your baby. I just gestated it for a little while.
I'm only passing it off to Dave. The tricky part of doing a two-person interview is I don't know necessarily who to ask the correct questions to.
That's fine.
And since it was sort of Dave's baby, I decided to pass it his way. But Nick, I mean, by all means, I
we're
believe
both competent, but I feel like Dave deserves this one.
All right. I'll give you the layperson version as best as I can. I always say that, and then it gets a little technical, but hear me out. Look, at the end of the day, I like to start it with metabolism. You hear the word all the time, metabolism. It's the balancing between anabolism and catabolism, the building up of stuff, the breaking down of stuff. And nowhere does that matter the most for us with human physiology than with the building up and breaking down of fuel. Well, if you're talking about glucose, it's pretty easily transported within the circulatory system because it's soluble in water. But if it's fat, if you're powered by fat, then it's a complex problem because, of course, that's not soluble in water, and our blood is water-based. So there needs to be carrier proteins that move it around inside of our body, right? So if I'm going to choose to be powered by fat, I need my body to have that system in place to work through. Well, the carrier protein you don't hear as often about is albumin. It's the most prominent protein in the bloodstream, and it's usually grabbing free fatty acids to move around to tissues. But the more famous one is the very famous ApoB, apolipoprotein B, and that's on not just LDL, but on the lineage of ApoB is VLDL, which comes from the liver, and chylomicrons, which come from the gut. So if I'm eating a whole lot of food, especially if I'm having a lot of fat, then my body puts them into this chylomicron, which is like a giant boat, right? Full of not just the fat for fuel, but also other things like fat soluble vitamins, other things that are not good about swimming in the water that is my bloodstream. That's the genius of the human body, is it puts them all into this one kind of boat. And then a chylomicron goes through and it like delipidates, it drops all of those off to tissues that need it. But to some degree, especially if it's chylomicrons during the feeding stage, a lot of that's going to go straight into my adipocytes, my fat cells, right? Correspondingly, while that's what's coming in the feeding state, on the other end is the thing I just mentioned, VLDL, which comes from the liver. VLDL are the boats, if you will, that are primarily transporting a lot of these lipids that came from storage from the adipocytes. So now that I'm not eating as much, now I need to draw more off of those VLDLs that came. What happens with VLDLs when they delipidate? They turn into LDLs. And unlike the chylomicrons, which get cleared right away, VLDLs that get cleared turning into LDLs, you can almost think of as empty VLDL boats they've dropped off their cargo, and now they'll remain in circulation for 2 to 4 days.
And
That's pretty relevant to me. That time span is pretty relevant to me because most of the things I've done in my early experiments, such as high fat feeding, I would look over a 3-day time span. And that's when you'd see the most direct result of the things that I consumed from the 3 days before when I took a blood test the following morning. LDL cholesterol is the cholesterol found in those LDL boats. And so when I am consuming a lot of fat, I'm actually driving down my LDL cholesterol, which sounds unintuitive, but the reason is because more of it's coming in from the diet, and it's stashing more of those lipids into my adipocytes. And it's also telling my body through a number of different chemical processes, which we talk about in the paper, to downregulate the VLDL that are coming out of my liver. And therefore, I end up with less overall LDL cholesterol. The other factor is I think that there's also much more absorption of the VLDLs as well with the expansion of adipocytes. This is so not layperson. Sorry, I totally went off.
No problem.
I know where you're going with this. I think we need to just like go back to the main.
You're right. But look, bottom line is this. The reason that we think that there's this triad for lean mass hyperresponders is because they are powered way more by fat, and they need to traffic it more. There needs to be a higher recirculation of it. Therefore, there ends up being more VLDL, triglyceride-rich VLDL, that's leaving the liver and very quickly dropping off the triglycerides and becoming the triglyceride-poor LDL. But on top of that, as that's happening, it's lipoprotein lipase is mediating it in the periphery. And that's resulting in more of the surface remnants of those VLDL. As they're shrinking, they shed these phospholipids and free cholesterol, which get picked up by the HDL species. And that explains why there's more and more HDL, particularly HDL cholesterol. And this process, because the turnover is that much faster, brings down the total pool of triglycerides. Again, a measure of fat in the blood. It sounds unintuitive because you're like, well, wait a sec, if you're like using more fat in the blood, then why don't, if you're saying there's more triglyceride-rich VLDL that are getting secreted, why don't we see higher triglycerides? It's because of just how fast they're getting turned over. The two of those two processes are coupled.
For those, let's just imagine the fasted state for simplicity. On a ketogenic diet, the liver will send out these big, just imagine them as big, huge spheres, these VLDL. Their cores are packed with triglycerides because you want to keep the triglycerides away from the watery part of the blood. Those big VLDL spheres will move over to areas around the body. And there's this other protein that kind of just sticks out on the blood vessels, and it will suck the triglycerides out. It's called lipoprotein lipase, so that the triglycerides can be turned into fatty acids, be brought into fat tissue, and be brought into muscle tissue and heart tissue to be burnt. And as that big, huge VLDL shrinks, because you're sucking stuff out of the core, the surface area around has to shrink, right? Because the sphere is getting smaller. So what ends up happening is that when the surface bits, including cholesterol, go off, they need to go somewhere. And so they get vacuumed up by HDL. And so you have more cholesterol moving over into the HDL, your HDL cholesterol goes up. And as that big VLDL is shrinking, its core is shrinking, it's losing surface components, it then becomes a LDL. So this is how you get that triad of low triglycerides, because like Dave said, the VLDL has been sucked out of all the triglycerides so fast, it becomes the LDL, which sticks around in the blood. And in that turning over process, you get the HDL. So that's how you get the triad. And the cool thing about it is the model predicts that the faster you have this turnover related to things like energy expenditure and adiposity, the more extreme the triad is. So what's really cool, in my opinion, about the model is it makes direct and testable predictions. So for example, if we hold everything else constant and we just make a lean mass hyperresponder fat, their LDL should go down. If we hold everything else constant and they're really active and we just bring down their activity level, their LDL should go down. So there's lots of different predictions. We have a wish list in the paper, but that's kind of the 50,000 foot view of how the lipid energy dynamics lead to this triad. That's beautiful. As lay person as I can make it.
I think that's great. And the paper is very, very well written. Kind of how I was imagining it is LDL is sort of this transporter that needs to go up because you're using a lot more fat as fuel. And so because your body is so reliant on fat, you kind of need more LDLs to traffic this fat around. And then triglycerides. And again, this is like my very not expertise in
Can we
lipidology.
tweak one thing?
Sure.
Can we just say ApoB lipoprotein?
Yeah, sure.
ApoB lipoprotein is the boat. The reason that they'll jump on us for LDL being the transport is, yes, it ends up being an LDL, but vernacular wise, they'll say, well, technically it's VLDL to start. That becomes an LDL after it's dropped off its triglycerides. But if you say ApoB lipoprotein, getting back to the carrier protein, it makes it a little bit easier. It's all that same lineage. It's all the lineage of ApoB.
Right. Appreciate that. And so since your body is using fat and ApoB is kind of the carrier of the triglycerides, you're using up the triglycerides. So your triglycerides are low. Your ApoB and LDL cholesterol is elevated because you need more to transport all of these triglycerides. And then can you help me understand, why does HDL go up in this scenario?
So for the reason we mentioned, so when you turn over those VLDL, so you have the VLDL, now let's imagine it, let's say it's next to a skeletal muscle, right? It's packed with fat. When the triglycerides get sucked out, when the lipoprotein lipase breaks down the triglycerides so that they turn into fatty acids and glycerol, but the fatty acids go in, the VLDL has to shrink, becomes an LDL. Where does the surface component go? So you sucked at the middle, that's the fat, the fatty acids from the triglycerides. The surface has lots of different things, including cholesterol sitting at the surface. So the cholesterol has to go somewhere else, and it's picked up by HDL particles, small HDL particles. And so then the cholesterol fraction of the HDL ends up expanding. And it gets a little bit more complicated because actually eating a high-fat diet can boost your HDL. So you can kind of bring not just the liver and skeletal muscles and fat tissue, but you can bring the GI tract in. So those chylomicrons Dave mentioned, they have a form of ApoB, but they're also enriched in ApoA. About 30 to 40% of ApoA comes from the gut. And when you're having turnover of those chylomicrons, rather than the VLDL, you can actually generate more HDL, which is really cool. So eating a high-fat diet kind of primes the body to have more acceptor particles for when you're then in the fasted state and the VLDL are shedding off the triglycerides. It ends up being really elegant.
It's like the body realizes that you're shifting over to using fat. It knows that there's going to be a lot more things that need to be sucked up, so it upregulates the production of HDL cholesterol.
Yeah, it necessarily as a function of eating higher fat. And then what the HDL are really good, much better than LDL via particular pathways, that efficiently moving free cholesterol back to the liver so it can be made into bile acids, which digest fat.
That's
so there's
amazing.
lots of superimposed.
Yeah. I would just add that I like to now just sort of describe, in fact, I probably should have just started it this way. I like to think of ApoB as something that starts big. It's meant to literally leave the gut or leave the liver as big and is meant to get small. It's meant to be a donator. It's meant to provide lipids, whereas HDL is meant to start small and then get big. Right. So it's meant to be the acceptor particle. It's literally on standby in larger quantities than the ApoB and ready to pick up the surface remnants and the cholesterol ester cargo. And that's that turnover is the middle portion, right? So lipoprotein lipase on the turnover is what's bringing the different aspects of these triglyceride-rich lipoproteins over to the HDL species. And I think that's the part that I probably wasn't as elegant bringing it back from before, but that I want to return to real quick. What does it mean when you have a failure of that turnover? What does it mean? Well, it means that you're going to have more triglyceride-rich lipoproteins resident in the blood, right? Not just higher triglycerides, but more VLDL. And you're going to have less and smaller HDL particles, right? And so that's that pattern we already see with metabolic syndrome, and it's very common. And I think, and I'm sure Nick probably agrees with me to some extent, is that it's probably a lot less successful lipoprotein lipase activity. There's less of that turnover process that's actually working. And I do mean to state it that way. It's less successful. It's not whether or not it's even being attempted. It's whether or not it's succeeding in its attempt to turn over these lipids as would be expected for the presence of them in the bloodstream in the first place.
Right. Thanks for that clarification. That really helped me conceptualize it. And I guess to bring it back, you mentioned in patients that are lean mass hyperresponders, what you've seen, at least in preliminary data, is that by increasing the carbohydrate intake just a touch, 50 to 100 grams per day, it sounds like was able to drop them, their LDL cholesterol levels back to sort of within normal-ish range. Is that because then your body is kind of switching back over to using, I guess, glucose for fuel and sort of starting to downregulate that entire process such that it's like, okay, we don't need this many LDL transporter or ApoB transporters anymore. Let's downregulate that. Is that the mechanism behind why that decreases?
I think this is one of the most challenging questions because implicit in it is the idea that the model, as we've explained thus far, would predict a linear relationship between fat fuel demand and LDL change, right? So if you eat, a 2,000 calorie diet, 100 grams of carbs is about 400 calories. That's only about 20%. So why would you see such a dramatic increase of, more than half, say 70% of your LDL? The numbers just don't work. So the reason we think that it's not per se a linear relationship, but maybe more of a threshold effect, is that there's a lot of hormonal signaling that we probably won't have the chance or depth to get into. But for example, I think one of the prerequisites for this model really kicking into effect is the depletion of glycogen stores in your liver. So, for example, when your liver glycogen stores get depleted, that actually is a trigger for a acute drop in leptin, which can have signaling effects to increase free fatty acid release in synergy with low insulin. So, again, layperson's explanation is eating more carbs can kind of bring your liver glycogen stores up, and the liver can act kind of like a switch. To determine, just how much this cycle is occurring. Because if you're not putting out the VLDL, then you're not going to have the increase in LDL. Even if you have high potential for LPL-mediated turnover lipoprotein lipase, you're not sending out the initial VLDL that'll come into the LDL to quite the same extent. So the liver can kind of act as a thermostat of sorts, and then a switch, turn it on and off, depending on liver glycogen stores. And if you top those up with some carbs, your LDL drops, and sometimes dramatically. So in the most extreme case, which was also the leanest subject in the case series, it was like he added about a sweet potato's worth per day of carbs. His LDL dropped by 480 from 665 to 185, which is absurd. It's like an order of magnitude larger effect than, a statin would have on average. And it's like a sweet potato, which is, again, just like, it's bonkers.
That's amazing. That's incredible. And do those people, are they still in a ketogenic state? Are they still in ketosis at that point if they do that?
They're so if you top up your liver glycogen, you won't be in ketosis. They're still low carb. So they went from like a low carb diet of less than 30 grams or less than 25 to more like under 130. So less than 25 is the colloquial threshold for ketogenic, although that's not a hard and fast rule. And then less than 130 is considered low carbohydrate. Again, very rough numbers, but
I guess my question is for those patients who are adamant that they want to continue to stay in ketosis because for the various therapeutic benefits, I guess anecdotally, have you guys seen any flare-ups in people who have tried to lower their LDLs by increasing the number of carbs? Have they had flare-ups in their IBD or any seizures or anything like that?
Unfortunately, per the Lean Mass Hyperresponder Facebook group, yeah, it's a challenge because, of course, a lot of people, understandably, different people have different levels of comfort with how high they're willing to, allow for their LDL to be. And so some people try finding, what threshold it is. But again, part of what's driving us a lot with this research is for those folks like, Nick, who this is a whole new lease on life in many respects for where they were medically before, but who may not be fully comfortable with the level of LDL that they're at. They're trying to find where that setting is. And for many people, like also that Nick mentioned with epilepsy, for example, I mean, I know some for which carbs are practically a peanut allergy. Like they have such a level of sensitivity. And I'm sure there's a lot more science behind it on that, but it's a challenge because for some, it's no big deal. In fact, I would say, I would go so far as to say most of the people in the group, most of the people in the lean mass hyperresponder group, adding back carbs and not necessarily being in ketosis is something they could hardly even notice if they didn't already have a medical reason to be becoming lean mass hyperresponders in the first place. And many of them are happy just doing that. But unfortunately for some, yeah, it's kind of a big deal because it's not, whether it's ketosis in particular, or whether it's just that, something associated with the fiber or many of the other aspects are just too counterproductive to their health goals. It can turn out to be something big for some.
Yeah, which is just adds so much more weight to your research and why it's so important to see whether, increased LDL cholesterol in the lean mass hyperresponder phenotype, whether they really are at increased risk for atherosclerotic plaques, coronary artery disease, or strokes. Because if they can just stay in ketosis, have increased LDL levels, and continue to gain mounting evidence, then perhaps they'll feel more comfortable and be able to sleep better at night. So that's awesome.
Very much heresy to say. Be careful. Trust us.
Really?
Propose. Yeah. I mean, I don't disagree with you, being candid, but yeah, it'll be interesting to see what the data say. Yeah. I think there's a lot of goalpost moving as things progress.
No, I'm very excited to see where the data goes. And obviously you are kind of the first to have a prospective study on this, but should there be results that show that thus far there is no increased risk, more studies will probably ensue after this. So this is very, very important work. But I want to leave time for the Q&A and be respectful of your guys' time. So before I ask my final question, where can everybody find you guys? What's the best way to support your research? We'll start with Nick, and then we'll go to Dave.
Yeah, I'm on Twitter at Nick Norwitz, so you can follow me there. And in terms of supporting the research, genuinely, we have 3 papers: the LMHR cohort study, the case report, which is an interesting clinical vignette, and the new lipid energy model paper. And in terms of supporting us, trying to read, or even just downloading and sharing those papers really helps. The more we can, amplify the research, boost read scores, that really helps, promote interest in this and help us do future research projects. So doing that, and then watching Dave's incredible video abstracts, it's going to become a staple. He's made one for the case report and now for the lipid energy model, and they are the video quality is top notch. So you have to go check those out. If you didn't understand our explanations of the lipid energy model, check out the video abstract and then tell me what you think. So you can thank me after that.
Absolutely.
And I'll pass it over to Dave.
They're excellent. Go ahead, Dave.
Yeah, I mean, exactly what Nick said. Look, the one challenge that I'll just say is we're trying to very respectfully bring this toward lipidology. Lipidology is, I've been knocking on their door this entire time, and I know that I understand why that there's not as much interest in this. But now that we have these papers in hand, particularly now that the lipid energy model is published, I look forward to trying to connect with more people who may have already been a little bit skeptical of this research to begin with. In fact, I'm actually going to be attending a conference next month, Lipid Association conference. We'll see how that goes. But my hope is that we can expand this. But this is, for anybody who's listening, this is something you can help us out on. The more that you share the papers and yes, the video abstracts, the more that we can get the word out, the more we can, move this conversation forward. Like, we could be wrong on either of these two, either on the model or on the risk. But regardless, I think we should all be able to agree that it's important for us to find out, that we should get this rolling. So with that said, yes, on Twitter, I'm Real Dave Feldman. And Citizen Science Foundation is our bona fide 501c3. So if you are gracious enough to give us a donation, it is tax deductible, and it's actually helping us fund the lean mass hyperresponder study and possible future studies once we get there. So those are the two places where you could definitely look for us.
That's awesome. And I'll make sure to link that in the show notes as well. And so for my final question, the same question I ask all the guests that come on here: if you had a magic genie and your one wish had to be, you could wish for the entire world to adopt one lifestyle modification that would most greatly impact or improve their health, what would it be? And we'll start with you first, Dave.
I'm going to get in trouble for this, but a healthy sense of skepticism.
Okay.
I honestly feel like your health, I feel like your health is improved by just being a little more proactive in trying to take time to understand things. And it's dangerous to say these days because, of course, there's a lot of potential for disinformation. But if you look under the hood, I'm not saying go ahead and trust the anti-establishment source. No, just be more skeptical in general. I wish that was taught more in school and in college, everywhere. I just think that it's a healthy engineering position. I'll just put it that way.
No, absolutely. That's great. And what about you, Nick?
I would say you need to make everything from scratch. So imagine trying to, you can't eat any processed foods. Like, you can go buy avocado, you can buy fruit, you can buy meat, you can buy veg, you can buy fish, whatever, but you have to make everything from scratch. So, if you want a cookie, you have to, get all the ingredients, make it from scratch. But, starting with that as a basic principle, I think puts people on the right direction in a pretty flexible manner. And I think you can get a lot of, move forward a lot that way.
Absolutely. Yeah, for sure. 100% agree. Awesome. Well, Nick and Dave, thank you so much for coming on our show. And guys, if you haven't already, make sure to check out that paper. Dave has shared it on Twitter. I have retweeted it. I'm sure Nick has as well. And let's increase the reads on that paper and support their research. But until next time, everybody, thanks so much.